I'm Bohdan Iwanskyj from the Coal Authority, Chartered Mine Engineer, and I work in the Heat and Byproducts Innovation team. A little background about the organisation to start. We came into being by virtue of the Coal Industry Act 94 to deal with the legacy of coal mining and was sponsored by the Department of Business, Energy and Industrial Strategy. We own virtually all the coal and mines of coal in the UK, which comprise some 23,000 abandoned mines and 175,000 associated mine entries, these being the shafts and adits by which people got into the mines, most of which have been treated to an unknown specification, presumably filled. Now we inspect these mine entries and those that are open we inspect on a more regular basis because we've got a responsibility to prevent people accidentally falling into the things. Many of our towns and cities prospered during the Industrial Revolution, where coal provided the foundations for industry to thrive. And so mining communities grew and the towns grew around them. And as we've heard before, we reckon about 25% of all homes and businesses are located on the coalfields, which translates into a huge demand for space heating. It's worth noting that space heating accounts for about 45% of all energy consumption and accounts for around 32% of greenhouse gas emissions. Our purpose is summed up in 4 key threads. First of which, to protect people. So that, surprisingly enough, is the same incident that Fiona had towards the back end of her presentation. We show the collapse, the remediation, the reinstatement. We also operate 2 mine gas hand stations to protect a couple of residential districts in the northeast. We protect and enhance the environment. So we've got 75 odd mine water treatment schemes that protect both surface water bodies as well as aquifers. We monitor water levels and build schemes to prevent new outbreaks of mine water occurring. We estimate that around 100 megawatt of geothermal energy is released from our mine water treatment schemes into the atmosphere, really. So to take a point from David Banks, there's a lot of waste there and a lot of opportunity to realise and benefit from that heat. Many schemes are located where mine water found its own way to the surface. Quite a number we abstract water from below ground, and the electricity bill that we have for the schemes runs around about £3 million per annum. Now, to offset some of that carbon cost, we've installed 1.6 megawatt of solar photovoltaics around our sites, and we use a small mine water source heat pump at one of the treatment schemes as well. Now, mine energy offers another clean means by which we can bear influence to enhance the environment by providing access to mine water at our treatment schemes and provision of information expertise to advise on the availability of a resource elsewhere. Our remit doesn't extend to that of becoming operators of mine energy schemes, I have to say that. This leads on to the third aspect of what we do. We're custodians of mining information. Specifically, we hold all coal mine abandonment plans on behalf of the Health and Safety Executive. The plans have been scanned and are free to inspect at our Mansfield office. Now, these are going to be available on the internet via the .gov platform in the next few months. We're currently going through a testing phase before the system goes live. So that's another great step change in terms of accessibility to information. Some of the plans, as we've seen, are very old, going back to 1700s, quality dubious at best. Now, legislation came into play that required plans to be kept and made to a certain standard. So most 20th century plans, specifically latter-day flat sheets, are precise and quite reliable. The information is used to provide various types of report to help people make informed decisions where past mining may have a bearing on their activities. These include residential mining reports, commercial reports for developers, as well as bespoke reports for specific inquiries. I saw in the chat there was an inquiry about some shafts in Kent, and if you were to contact the mining information team, they can make that information available, as is the case with any other mine entries around the country. Information is used to evaluate requests for us to issue permits to enter or disturb the coal mining estate, and we use it to help evaluate coal mining risk assessments. Coal mining has all but ceased in the UK. Imports are falling as we embrace the need to reduce carbon emissions to address the climate change emergency that we face. But the legacy left by mining presents some interesting opportunities. And so another of our key aims is to create value and minimise cost to the taxpayer. In 2019, the Environment Agency predicted that England could experience water shortages within 25 years. So we potentially have resource that can be exploited by virtue of the large volume of water that we treat. The ochre sludge that is created by mine water treatment process has been used to remediate contaminated land. Mersey Gateway, large civil engineering project, 8,000 tonnes of arsenic contaminated soils were treated with ochre, which enabled the material to be retained on site and so avoided disposal in landfill. A good sustainable result there. Other high-grade products are being developed from ochre too. Applications generally require the ochre to be quite dry, and so we are investigating the opportunity to utilise mine energy as a means to dry the sludge that's recovered from our lagoons. If our trials are successful, we could see our first low-carbon, zero-waste mine treatment scheme in the northeast, as we have sufficient room to construct about a megawatt of solar array there, and that will offset a good chunk of the 1.4 gigawatt hours of electricity that we consume there every year. So, mining, long history. We've heard people talk about experiences of the family and all sorts. In earnest, peak production was around about 1900. You can see some early photographs of some very small operations, people, winding coal out of a shaft, and then down below, you know, we're way into post-war era where you've got the colliery railway system taking miners to the face. Coal output's been shaped by political events, you know, post-war nationalisation, sort of increasing mechanisation, transition from steam power to diesel, industrial disputes, and so on. Although great efficiencies were achieved through mechanisation and integration of resources, the economics of deep mining were no match for the cheap imports and the dash for gas, nuclear energy as well, offset the demand. Last of the large collieries abandoned in 2015, that was Kellingley, which supplied power to the Ferrybridge power station. So, in essence, coal has had its day. The frequency and extent of time that the electricity generators produce power without coal-fired capacity is growing all the time. But the mining legacy offers a viable opportunity to play its part in today's energy needs, specifically space heating delivered by district heat networks that utilise the mine water. And for every kilowatt of electricity input, the heat pumps will produce 4 kilowatt of thermal energy output. Mine abandonment. So when the mines were operational, water was abstracted to keep them dry, and in fact there are a great many collieries that were eventually closed because the operators couldn't keep up with the influx of water. And of course, when collieries closed, so pumping ceased, mines flooded and water levels slowly recovered to pre-mining levels. Water levels in many coal mining areas have fully recovered, but not all. We're monitorising mine water so that new treatment schemes are built in time to prevent new raw mine water pollution affecting aquifers and surface water courses. Again, from Gareth Stork, it's a simple truth that the deeper the mine, the hotter the working conditions. And those conditions have been found to persist long after the mines were abandoned and flooded. And there on the right, you just see a UK-wide snapshot of the combined sort of like mapping that's been produced by BGS and ourselves. And a little slot there to show the types of temperatures that we believe are present there. It's a very useful tool for anybody interested in taking a preliminary look to see what heat might be available. But a word of caution, the maps don't show the depth to which mine water has recovered. Subject to resources and our constraints, we can quickly provide a slightly more in-depth view relating to any specific site, enough to say whether or not it's worthwhile progressing a mine and to a mine energy feasibility study. We're quite happy to do that. Total resource equates to something like 2 million gigawatt hours, enough to heat 100 million homes. Now, clearly, it's not all available, and there are huge areas where it's just not economically viable. But the point is, it's a massive resource, and there are opportunities that can be made to work. I think we're all familiar with the concept here. Mine energy, mine water is heated from the Earth's core as opposed to the near surface ground source heat, which relies on solar energy that penetrates relatively shallow depth from the surface. Typical temperatures, as Gareth explained, around about the 12 to 20 degrees from our mine water treatment schemes. Deeper you go, the hotter it gets. Our deepest mine was actually 1.4 kilometres depth. We've recorded temperatures at a number of our sites over a number of years, and they remain remarkably stable. So at Dordon, for example, a treatment plant in the northeast at Durham, we've been tracking temperatures for the last 10 odd years. It's a treatment scheme where we abstract 80 litres per second, and the temperature has never varied from the 19 degrees centigrade by more than a degree over that entire period. Many of the mines were abandoned and the shafts were filled, so accessing mine water now may require the drilling of wells. And there are risks, as David Banks explained earlier. In such cases, there's a balance to be struck between targeting deep hot water, which may incur high capital expenditure, the operational cost associated with pumping. Now, if the recovered mine water is close to surface, then the pumping costs of abstracting water from deep wells don't necessarily break the bank because the pumping head isn't massive. But these are all subject to investigation. A couple of slides that show the type of working, a couple of slots, photographs that actually show what they actually look like in real life. The slide illustrates, so that's that. Early mining was typically pillar and stall, which we see on the left. The photograph was taken on an open cast coal site that uncovered an area of old pillar and stall workings. Now, typically, the stalls or the gaps, they are filled. But, you know, I've spent best part of 20 years on open cast sites. There is any amount of water that actually comes into the open workings, and you can see open roadways in high walls and the water gushing out. So notwithstanding that many of these are filled with roof falls, floor heave and whatever, there is still transmissibility there for water to pass. The middle section shows a more modern style of longwall mining and the type of plant that was used to create the long headings on either side of the operational panel there. Quite a modern picture because you can see the roof supported there by rock bolts rather than the more traditional steel arches. Underground roadways are quite extensive. In modern pits, you know, miners will go down the shaft and then they would commute to the face. You know, you could have a half-hour, 45-minute journey underground to your place of work. To contemplate the development of a mine energy scheme, it's essential to have a thorough understanding of the mine system, interconnectivity between seams, interconnectivity between collieries, an understanding of flow pathways, interconnectivity for one mine system is depicted in the diagram on the slide there. So you can see a number of shafts, a number of seams, and those sort of like orange coloured lines are depicting roadway connections between various levels within the mine. It's also important to understand that, you know, there's an awful lot of prospecting boreholes that have been sunk around the country. In theory, all properly sealed. In practice, maybe not the case, and they present potential pathways as well. Particularly important if you're developing a scheme that's going to abstract water from one well and re-inject elsewhere. So important to understand the potential for short circuiting there. From 2025, new residential developments will not include provision of gas for space heating. Good alternative air source heat pumps is there, proven technology. But mine water has a distinct advantage that temperatures are consistent day and night all year round. There's no cooling effect in winter when heating is at peak demand. This is one of the reasons that mine energy has been recognised as a valid, viable source of low carbon space heating, and this is reflected in interest we see from local authorities and others. Mine energy schemes require a fair capital commitment to so there needs to be a reliable anchor load. And again, we've heard this thread previously. So in terms of organisations that have large space heating, these are ideal candidates to contemplate building these schemes. And to that end, you know, the Crown Estate presents good opportunities. You've got the public buildings, schools, hospitals, council offices, leisure centres, libraries and so on that can provide that anchor load. New developments offer a great opportunity because the layout of estates can be designed with district heat networks in mind. Particularly exciting prospect at the present time relates to South Seaham Garden Village, which is located literally a stone's throw away from an existing mine water treatment scheme at Dordon. We already abstract the water there, so that's a tremendous boost to the economics of the whole concept and the scheme there. Development comprises about 1,700 homes, a community centre, a school, and the first houses are scheduled to be completed in maybe a year to 18 months' time. So watch this space. It could be the first large-scale mine water energy network scheme in the UK. So here we have the benefits of mine water energy. Low carbon solution for space heating. There are also opportunities to design seasonal storage of heat where circumstances are right. For example, utilising surplus energy generated from renewables to heat water when consumer demand is low. For this purpose, it's possible to utilise potentially an abandoned shaft or isolated pockets of workings. You know, you think of them as a large underground flask storing heat. There may be opportunities associated with horticulture, maybe aquaculture, to improve their position with food resilience. You know, we spend billions on importing fresh fruit from abroad. The challenges presented by climate change cannot be overstated, and time to implement change is really against us. Mining energy accords with mining communities. We understand that coal mines provided the resource to heat our homes. It's familiar territory and will help to smooth the transition away from gas. It may help to alleviate some of the fuel poverty and create jobs in the communities as well. So a real social benefit there as well. So all in all, mine energy presents a great opportunity to create a better future for people in mining areas. And with that, I'd like to conclude this particular presentation. Thank you for listening.